Hi and Assalamualaikum. I'm Nur Atikah Idayu binti Nurlizan. In this video, I want to share you about some of the topic of the quantum physics, which is photoelectric effect. So, based on this subtopic, you might have guessed involves two things, which is light for photo and electron from electric. Therefore, let's get through more detail about the meaning of photoelectric effect. Here are the meaning of photoelectric effect. When the surface of the metal piece is illuminated by a beam of light at a certain frequency and energy, electrons can be emitted or ejected from the surface of the metal. This phenomenon is known as photoelectric effect. Now, let's see how this happens. Here, a figure of a metallic piece. Also, a source of light is present over here when light is allowed to incident on the surface of the metal. And then, the electron from the surface of the metal gets ejected, and these electrons are known as photoelectrons because these are ejected by the action of photons. Now, here a question arises. Is that light of any energy can eject the photoelectrons from the surface of the metal? So the answer is no. Why? Because electrons can be ejected or emitted from a metal piece only when the frequency or incident radiation becomes either equal or greater than the work function of the metal. Let me show you an example. Here, I'm gonna use a red light as an example because red light has a relatively low frequency compared to other light. So for most metals, if you shine it with red light, it's not going to be enough. Red light doesn't have enough frequency or enough energy to eject an electron for the surface of this metal. So it doesn't matter if you increase the intensity of the red light. If you shine more red light photons on this metal, no electrons will be ejected off this metal. Now, let's say if you shine blue light which has a much higher frequency than red light on this metal, then electrons will be ejected off the surface of the metal. And if you increase the intensity of the blue light, let's say if you add more photons on this metal surface, more electrons will be ejected off the surface. So now, let's go through into the experiment of the photoelectric effect. Here, I will sketch and show you the apparatus. So, based on this circuit, we can also study the characteristic of photoelectric effect. As we can see, the metals of the cathode is surrounded by electrons. So, the first characteristic is when you shine the light into the cathode's metal with the right kind of light and the right kind of frequency, we actually see electrons will be emitted from the metal surface. These electrons are called photoelectrons. Second, after the electron being emitted, then it will be attracted to the anode which has positive potential. And lastly, the movement of the photoelectrons for the cathode to the anode can produce a current inside the circuit to flow, and the milliammeter will show you the value of the current. So here I will rewrite the characteristic of photoelectric effect. So first, when a light-sensitive metal surface cathode is illuminated with a certain light beam, electrons will be emitted from the metal surface. These electrons are called photoelectrons. So next, the emitted photoelectrons are attracted to the anode, which has positive potential. Then lastly, the movement of the photoelectrons from the cathode to the anode produces a current inside the circuit. The milliammeter shows the value of the current. So here are all the characteristics of the photoelectric effect. Therefore, I hope this short video can help you input a strong understanding about the meaning of the photoelectric effect and also the movement of photoelectrons. So that's all from me. Thank you.